Okay, starting with number 1. Okay, the first thing, I heard some of you struggle, and I've told you this time and time again. I see y equals. What do? Make a table of values. Okay, now, I don't want a whole table, though. I need to look at the limit. It says 0 plus. So do I want numbers bigger than 0 or smaller than 0?
Bigger.
Bigger than 0, okay? All right, so I'm going to go ahead and I'm going to translate this. So this really means 4 over the cubic root of x, which I think I heard somebody in the back mention to somebody. Okay, so I know 0 doesn't work because 0 put a 0 in the denominator, so there must be some sort of an asymptote at 0, okay? So I'm going to go with 1 because 1 is bigger than 0. So if I plug in 1, that is 4 over the cubic root of 1, which is 4 over, what is the cubic root of 1? 1, because 1 times 1 times 1 is 1. And 4 divided by 1 is 4. Great. Because I know what I want to do the cubic root, I'm going to pick numbers that I can do the cubic root of. So next I'm going to, yeah, good call, 8. So I'm going to choose 8. And the cubic root of 8 is 2. So 4 divided by 2 is 2. And now I'm going to pick 27, and the cubic root of 27 is 3, and 4 divided by 3 is 1.3 repeating. Yes? Now I'm going to come over here. Now, you might be able to pick up enough from this. I can't. I can see a pattern, but I will tell you that I am very much a visual learner. I need to see a picture, and then I can analyze, and I can make summaries and those types of things. So I'm going to make a quick little plot. So 1 and up to 4. And then I'm going to go to 8. So 2, 3, 4, 5, 6, 7, 8. Remember, it's just a rough sketch, and I'm only going to go up to a height of 2. And then I'm going to go all the way out to 27. It's going to be somewhere there, right? So now I know my graph's going to look something like that. Okay? And the question wants to know as I get to 0, as I'm heading to 0. Okay? So where is 0? What else is 0? X equals 0. What? It's the vertical axis, right? It's the y-axis. So let me go ahead and highlight it. Here is 0. Where is that function going to touch on that fence, on that line? It won't. It's going to go to infinity. Okay? So you could say infinity, or you could say it does not exist, but it's going to infinity. That's its behavior at that location. Cool? Good? Kyle, what's your question? Okay, so 4 divided by 3 is 1.3. Because I know I want to do the cubic root. So cubic root means 3 of a kind. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So I just knew, based on when I was younger in math skills, I know that 27 is a cubic number. 64 is a cubic number because 4 times 4 times... Cubic means 3 of some number multiplied time itself. Okay? Yes, those are helping me make a sketch. Yes. Just like if I ask you your perfect squares, what are your perfect squares? 1, 4, 9, 16. So these are my perfect cubics. It's something you just need to familiarize yourself with. Or worst case scenario, this means 3 of a kind. So pick a small number like 1. 1 times 1 times 1. 1. 2 times 2 times 2. 8. 3 times 3 times 3. 27. So that gave me a starting point. Now I can plug into the formula. I can get an output. So then I graphed my input with my output. My input with my output. My input with my output. So I can make a sketch. This is the work in between to get from input to output. Yes? The 1.3 with the line over it? Because 4 divided by 3 is 1.3 repeating. It's a repeating decimal. Mm-mm. That's a decimal point. Yes. But it's not asking about when it's heading towards infinity. It's asking when it's heading towards 0. What's happening to the graph? If I asked you as the graph goes to infinity, if I said as x heads to infinity, you would say the output is where is this heading? 0. It's getting closer and closer to 0. It will never cross over. It'll get for something like that. Yes. Okay? I am now going to move on if that's okay. Okay, so that's what I just went over. The cubic root of 1 is 1 because 1 times 1 times 1 is 1. So 2 times 2 times 2 is 8. So the cubic root of 8 is 2. Okay. Number 2. Which best describes the symmetry of a function? All right. How can I test the symmetry of the function? Who remembers? What do I sub in? What value? But you did give me a good idea. What value do I substitute in? What do I, guys, this was in the last unit. How do I determine even and odd? What do I replace x with? Negative x. Thank you. So, this translates to 7 times the fifth root of x to the fourth power minus the absolute value of x plus 3. I went from power function, so exponential form, to radical form. Everyone okay? All right, so now I'm going to do 7, the fifth root of negative x to the fourth power minus the absolute value of negative x plus 3. Well, what happens when I take a negative number, to an even power? It's positive. If I have an even power, it will always come out positive. Even power always comes out positive, right? So this is going to stay 7, the fifth root of x to the fourth power. What happens when you take the absolute value of a number? It becomes positive, right? And then can 3 change? Can 3 change? Why can't 3 change? It has no x. It has no variable. Okay? So everything matches. It's even Steven. So it's an even function. Let me give you a heads up right now. In order for it to be odd, everything has to switch signs. If I have a constant, can it ever switch signs? No. So if it has a constant, can it ever be odd? No. If I see a constant, it's either going to be even or neither. Even or neither. How do I know something is a constant? Somebody said it a couple minutes ago. Doesn't have a variable. A constant is a number without a variable. It stays constant. You can only change if you have a variable. So if you have no variable, you are a constant value. Cool? Can I repeat? Here? Okay, remember, if I have a negative and I take it to an even power, so negative times negative times negative times negative, this becomes a positive times a positive, which is a positive. If you have an even number of negatives. Now, guys, time out. If this had been 3 instead, right? If this had been a 3, this sign would have changed. Would this sign have changed? No, because absolute value is absolute value. Okay? So change, no change, no change. It would have been neither. Okay? Yes. If it had an odd power, that first term would have changed signs. This has an even power right here. What happens if you have an even number of negatives? Positive. If I have an odd number of negatives, it's negative. Okay? Because you have to partner up to make a positive. A negative times a negative. If I have 3 negatives, 2 partner up, I got a solo. Not happy. Nope. Good? Okay. I am moving on. Okay. So, below are 3 different functions. And I'm going to call them f x to the a power. I want to know the power. So, what is this one? What's the equation for this one? I skipped 3. All right, well, let's go to 4. I hope 3 is still there and I didn't delete it. Okay, so talk to me. Okay, so let's look at the first one. This is a graph of what? X squared, which means a is equal to 2. This is a graph of, so write it using exponents. So you said the square root of x, which is x to the 1/2. What is this a graph of? Cubic, which is x to the 1/3. Cool? Those are your parent functions. You should know your parent functions. Hopefully I did not delete the slide. Let's find out. All right, so that's the one I skipped. I put them out of order. Sorry. Okay, so this takes you down memory lane. This takes you down memory lane. This is from Algebra 1, Algebra 2, and Geometry. All discuss this. I'm going to hold off on this first piece. I'm going to go straight to reflected over the y-axis. How do I know it's reflected over the y-axis? Negative. I'm going to put a big old negative out front. Okay. How do I move left 5? It's positive. X plus 5. Now, right? Because standard formulas are x minus some value. You know how I remember it? I don't do that. I just remember my x is crazy, so whatever is with x is the opposite. So if I want to move to the negatives, it's positive. If I want to move the positives, it's negative. Cool? All right, remember that number I said let's hold off on? Let's go ahead and use it. Where does it go? It goes as the power. Okay, and now how do I move down 3? Minus 3. Now, you don't need to know this for this round, but in future, this is reflect y. If the negative's up here, it's reflect over x. Okay? On the test, it's not going to be that pretty. It's not going to be that pretty. You got to do a little thinking. So let me give you some thinking. They're going to tell you something like, I had an ordered pair at 0, 0, and now I have an ordered pair at negative 5, 3. What did I do? Well, I don't know about the reflection yet, right? I went right 5 and up 3. So that would be x plus 5 plus 3. Yeah? Right. I was just talking about it's not going to be that simple. It's not going to be in word form on your test. It's going to be in picture form. So I gave you an example. If this is A and this is A prime, you remember that from geometry, what happened? All right. Here we go. Rewrite as a power function is the next question, right? Okay, I got to steal your paper. No, I got one right here. So the first one is negative 5 cubic root of x. So what should I write on my paper? X to the 1/3. Easy peasy lemon squeezy? Awesome. All right. The next one, y equals. This one has more than one correct answer. Let's see if we can get it. What do we think? Like this? Nope. That's not correct. So one correct answer is 2x to the 3 halves. That is one correct answer. What's the square root of 4? Now, if you wanted to, you could have also done 4x to the third in parentheses. Why am I putting them in parentheses? Parentheses means group, grouping symbols. They are grouped together under the radical. What power is a radical? 1/2. So you could say this or this. Both are correct. Cool? And the last one, a little bit easier. Y equals 3 over x to the fourth, which is y equals 3x. Why is it negative 4 and not just 4? Because it's in the basement. It's in the denominator. Okay? All right. If everything's on the square root, you put them all in the parentheses because they're grouped together, and parentheses are a grouping symbol. Yes. Yes. So the 4, the power of 4 is in the denominator, so that's why it's negative.
All I heard is negative basement. So why did you put the 3 and the x together? Oh, wait, never mind.
All right. Because remember, that's a good question. This is also the same as 3 times 1 over x to the fourth, yeah? So I just changed that to this. Cool? All right. Okay, so if y varies inversely as the cube root of x squared, so let's start. Y varies inversely the cube root of x squared. So what would that look like? No, we're not there yet. I just want to start with this first part. Cube x squared. Okay, so y equals k over cubed of x squared. Great. Now, what do I know? Yeah. No, I'm going to check it tomorrow, hon. I was running, I've had a crazy day, so we're going to go over the homework tomorrow. Your homework was 3 of these. It's slightly shorter than this review. All right, so talk to me. X equals what? 27. So I have 5 equals k over the cubic root of 27 squared. Now listen. Okay, listen. You could use your calculator or simply, it doesn't matter if you take the cubic root or if you square the number first. I like the cubic root first. So if I take the cubic root of 27, 3 of what number, the number times itself gives me 27. 3. What's 3 squared? 9. So 5 equals k over 9. Okay? You could have put it in your calculator. Doesn't matter either way. Yes? If I do 27 squared, it's 729. If I do the cubic root of 729, it's 9, because 9 times 9 times 9 is 729. I prefer to do cubic root first, and then square the number.
Why is it squared?
Because it says the cube root of x squared. So what is k worth? K equals 45. So now I'm going to go back up here. You follow? All right. So now I'm trying to write a formula. So y equals 45 over, if I want a formula, I got to keep what 2 variables? X and y. Okay, so this is in radical form. Now you can understand why I put problem 5 on there, because on the actual test, there is no problem like problem 5. This is the problem on the test, right? You got to solve this, but they want it in power form. That's why I put question 5 on there. It's a skill. It's converting form. So what is this in its final form? Y equals 45. x to the negative negative
Yeah.
2/3. Why is it negative?
Because it's on the
Because it's in the denominator. It's in the basement. Now, if you forget, root power. And when I write the fraction, it's power over root. So if you forgot, review that, okay? The root is always on the little arm of the radicand, and the power is inside of the radicand. And when you write the fraction, it's power over root. It's alphabetical, power over root. Order pairs, alphabetical, x comma y, yeah? Most things are alphabetical in math. Yes. So, the cubic root of 27, if I break down 27, that's 3, 3, 3. So I have 3 3s. You can. I explained it. You could do it either way. If I square 27, I get a really big number. I get 729. And then I have to do the cubic root of that, which is 9. I prefer to do the root first to get the number smaller. So the cubic root of 27 is 3, and 3 squared is 9. And I also did that because I knew 27 was a special cube. If you can recognize it, that's why you might do things in a certain manner. Okay? All right. Here we go. The next and the final question is, which grows faster, x squared or x cubed?
X squared.
How could I know? You can make a table of values. You could graph it on your calculator. You could type both equations in your calculator and go to second graph and look at the table of values. So let's talk about it. What does cube mean?
3 times.
Right, so this means x times x. This means x times x times x. Which one's going to get bigger faster? Cubed. Let's summarize it. How do I know which one's getting bigger faster? What's its shortcut? The larger, the higher the power, the faster it grows. Okay, so the next one was x to the 1/2 versus x to the 1/3, right? So the square root of x, the cubic root of x, right? So if I do 1, the square root of 1 is 1. The cubic root of 1 is 1. If I do 8, the square root of 8 is between what two numbers? 2 and 3, so it's 2.5. And the cubic root is 2. Which one do you think grows faster? The first one, 1/2. Okay, this is unnecessary. What did you tell me a couple seconds ago? How do you know which one grows faster? The bigger the power. So, the final question asks you, or one of the questions, sorry, says x 5/4 versus x 3/7. Oh my gosh. Oh my gosh, it's fractions, Ms. Olenek. Why are you giving me fractions? Oh, my head's going to explode. So, let me tell you, I wish your teachers had taught you this in elementary school, but they probably didn't. Remember, I try to make things super easy for you. So whenever you want to compare two fractions, you simply cross multiply. So 5 times 7 is 4 times 3. Which one's bigger? 35. So 5/4 is bigger than 3/7. So which one's growing faster?
You said, wait, so
That's how you compare fractions. Now, what happens if I put a coefficient in front? Does it matter? Does it matter? No. It's called a power function because that power contains all the power, all the control. Cool? All right, so that is your review for today. Good luck tomorrow.